let's talk about indexes. So an index is an additional data structure that's added to a collection to allow you to do quick lookup based on a particular field or fields. So let's just look at an example. Let's say we want to have an index on users.name. And so there are some default indexes that Firestore will already create for you. So basically, if you have any non-array, non-map fields, it will go ahead and automatically create indexes on those for you. There are two types of indexes. So there's an ascending and a descending index. And so if you have the name, what that allows you to do, for example, is do ordering. So you can sort either in alphabetical or reverse alphabetical by using this index. Without the index, if you retrieved 1,000 users and wanted to sort by name, you'd actually just have to do an in-login sort on those 1,000. Okay, or if there are 1,000,000, it's even worse. But the index will allow you to do that in linear time. The second thing the index, so these allow sorting. And again, depending on which index it is, you can sort alphabetically if it's ascending or reverse alphabetically if it's descending. And the other thing this allows is equality testing. So you can do exact testing in linear time. You can also do less than, so ordering basically, less than, equal, greater than or equal. Okay. So these are all the types of queries that can happen given an index. So if you want to go look up a user by ID, right, that would be equality testing. That's an order 1 operation, not an order n operation. Requires, of course, auxiliary storage to store this index, and requires when you are updating a document and changing a name, for instance, it changes not only the name for that document, but also it then has to go change the name index, the auxiliary information. And you have to pay for that, right? You pay for the indices because they take storage, and so they're going to cost extra storage. And there's also a maximum number of indices you can have for a particular collection. So you can have indices on these first level fields. So if you have, for instance, a user, right, this is the user in users collection. And you've got a name, and then you've also got, let's say, a address. And this address is itself a map. So you've got city, state, zip, and so on. Well, now, if you wanted to find, for instance, all of the users whose address was in a particular zip code, so you could say, DB, and I'm not going to put the exact syntax here because we're going to talk about syntax later, but basically get users where address .zip equals 91768,